So this is a short video just to explain why reactions are exo or endothermic. There's an additional video which deals with the bond enthalpy calculations to show how you actually work out the energy change during a reaction. This one just deals with explaining and how you tell an examiner why a reaction is exo or endothermic. So the first step of any reaction, and the first step that you have to understand, is that when a reaction happens, bonds and reactants have to be broken. And if you remember earlier in the topic, we talked about the activation energy. So the activation energy is essentially the energy that you put in to break these bonds. Okay, and we'll look at a little animation in a couple of seconds which will show this in a bit more of a visual manner. So that part of the reaction is endothermic. So remember, whether a reaction, an entire reaction is exo or endothermic, okay, it's different from us saying here at this point that whenever you break the bonds in the reactants themselves, that part of the reaction is endothermic. What then happens is when all those bonds are broken between the molecules of the reactants, you get free atoms, because all the bonds are now no longer there, the atoms are now free to move, and those atoms will join up with new atoms that they're really strongly attracted to. And what they'll do when they join up with the new atoms is they'll form new bonds. And the complete opposite to what happens whenever bonds are broken and energy is needed, that's an endothermic part of the reaction. Now, when new bonds are formed, energy is given out. That's an exothermic part of the reaction. So in every single reaction that happens, every chemical reaction that happens, you have an endothermic part of the reaction, bonds being broken in reactants, and you have an exothermic part of the reaction, bonds being made in products. And it is therefore the balance between the amount of energy in to break those bonds and the amount of energy that's given out whenever the new bonds are made that determines if the overall reaction is exo or endothermic. So for example, if more energy is taken in to break the bonds than is given out when new bonds are made, overall that reaction is going to be endothermic. There's more energy being taken in. If more energy is given out when new bonds are made than is taken in when the old bonds are broken, that reaction is going to be exothermic overall. So if we look at this animation here, these are our reactants on the board. We have methane, which is CH4, carbon, singly bonded to 4 hydrogens, and it's reacting with O2, molecules of oxygen, diatomic oxygen, with a double bond between each oxygen. And if we look at what happens, if you look at the bonds, they start to disappear. We're giving this thing the activation energy, and the activation energy is breaking the bonds. And just like any attraction, you know, if you stuck your two hands together with glue, to overcome that attraction, you have to put energy in. It's exactly the same here. We have had to put energy in to break all of those bonds. That's the endothermic part of any chemical reaction. Once I've done that, these atoms are now free to move, and they're now free to bond with new atoms, atoms that they are more strongly attracted to, and that's exactly what they will do. And you can see here, we've gone from having our methane and our oxygen on the left-hand side to now having our products, and our products are water and carbon dioxide. And new bonds have been made in this instance between hydrogen and oxygen, and between hydrogen and oxygen here, and between carbon and oxygen over here. So when those new bonds are made, energy is given out. In total, what we've done here is we have broken 4 single carbon hydrogen bonds. I'll just go back to show you. We've broken 4 single carbon hydrogen bonds, you can see them there, and we've broken 2 carbon oxygen double bonds. So that process is endothermic, and energy goes in other words, in that part of the process. Then, what we've done when all those bonds are broken and the atoms have rearranged, we have made two carbon oxygen bonds are formed, and 4 oxygen hydrogen bonds are broken. Earlier I had 2 oxygen bonds broken. So I have formed 2 carbon oxygens, and I have formed 4 oxygen hydrogens in the 2 water molecules. And when that happens, we get an exothermic part of the reaction, and energy is simply given out. And it is the balance between this energy given out and energy taken in that determines whether the reaction is exo or endothermic. So for example, like I said earlier, and I'll just go over it again because it takes sometimes a little while for this to bed in. If the energy in is greater than the energy given out, then the overall reaction is endothermic. If the opposite is true, If the energy given out is greater than the energy taken in, then the entire reaction is exothermic. Okay, so in conclusion to that, guys, remember, you have an endothermic part of every single reaction. It is the energy needed to overcome all those bonds in the reactants. You have an exothermic part to every reaction. It is the energy given out when the new bonds in the products are made, and it is the balance between those two processes which determine whether an overall reaction is exo or endothermic. And that's pretty much what I've said in this summary screen. Now, let's say you had an exam answer today, and it says you're being asked to explain whether a reaction is exo or endothermic. So you always state that bonds are broken in the named reactants. So don't talk about general reactants. Say the named reactants. For example, in the last example, it would have been the bonds are broken in methane and oxygen, and that requires energy, which is endothermic. Okay, you then say that the energy is given out when the new bonds are made in the named products. So don't, like I said earlier, don't just say generally the products. Okay, in the last example, I would say in carbon dioxide and water. And if the overall reaction was exo or endothermic, then I would make a statement about the balance between energy going in and energy coming out. For example, if it was exothermic, I would say more energy is given out when bonds are formed than is taken in when bonds are broken. Okay, so if we look at an actual example, the bonds in methane and oxygen, the reaction in methane and oxygen is exothermic, tells us, explain in terms of bond making and breaking. Very simple. We say the bond in methane and oxygen must be broken. Energy is needed. 2 marks you'll get for that. The bonds are formed in carbon dioxide and water. Energy is given out. 2 more marks. More energy is given out due to bond making in the products than is taken in during bond breaking in those reactants. No need to name them the second time. So the reaction is overall exothermic. Dead simple. If we had an endothermic reaction, we would go through exactly the same process. Our endothermic reaction here is photosynthesis, where carbon dioxide and water combine to give us glucose and oxygen. And we would say the bonds in carbon dioxide and water have to be broken. That's an endothermic part of the process. Bonds in glucose and oxygen, the products, are made. That's an exothermic process. This overall reaction is endothermic, so we make a comment that more energy is taken in breaking the bonds in the reactants than is produced when the bonds are made, or bond formation, in the product. So overall, that reaction is endothermic. Okay, so that is the idea that you use whenever you're just explaining whether a reaction is exo or endothermic. No calculations, as I said, they're done in another video, but I think you need to be able to do this. This in an exam, by the way, this type of question in an exam, normally worth 4 or 5 marks. Okay, so it's important that you're able to explain it, and you're able to explain it in a logical sequence order using technical phrases and words, the correct ones, okay, and answer it as per those model answers. I hope that helps, guys.